Hey Braves! So this week we're talking about chemical and physical properties and chemical and physical changes. Now, you should remember a lot of this from last year when you were in Mr. Fisher's class at the middle school. But before we get into the more complicated things like chemical reactions, we want to make sure that you understand what a chemical reaction is, which would be a chemical change, and how it's different from physical changes. So this week is all about clarifying those very simple concepts. Now, you're probably sitting here asking yourself, well, what's the difference between a physical property and a chemical property? Let's be honest, you're not asking yourself that, but I'm asking you that. So what is the difference? Well, physical properties are characteristics of the substance, whereas chemical properties are how that substance interacts with other types of matter or other substances. So a quick example would be, for instance, this glass beaker here is smooth. That's a physical characteristic. It's hard. It doesn't feel so good when I hit it on my head. It's dense, meaning there's a lot of atoms in a small amount of area. It's really squeezed together. It has a melting point. If I take this blowtorch and I heat this glass for a very long time, it will eventually reach its melting point and melt and turn into liquid glass. And if I were to heat it up even further, I might even be able to create glass gas. I could actually vaporize it, so it has a boiling point. So these are all physical characteristics. Characteristics about this. It could be what it sounds like when I take my finger and flick it, as opposed to when I take my finger and say flick that cup. They sound different. It's because the waves of energy move through them at different speeds and they put off a different pitch, right? So these are all physical properties. Now, here's a list of all the physical properties for you on the screen. It's pretty awesome. It's right there, man. I just came right out of my mind. Now, chemical properties are a little bit different. The only way you can really discover a chemical property is by seeing how it changes into something else when it interacts with another substance. So basically, it's going to no longer be whatever it was that you started with. That's things like flammability, right? In order to set something on fire, well, I'm now changing it. If I burn a piece of paper, that paper is no longer paper, it becomes CO2 and water, right? So that would be a chemical property, because in order to witness that chemical property, I would have had to have changed the substance in some way. And taking this blowtorch to something is a great way to change what that thing is, right? So that would be things also too like toxicity. If I eat a particular poison, well, it's going to interact chemically with the different parts of my body to make me sick. Maybe I swallow a whole bunch of bleach. Well, it's going to do all sorts of nasty stuff on the inside of me once it gets in contact with the different substances in there. So that would be a chemical property. Other things are like pH. How acidic is it? Is it very acidic? Would it burn my skin if I put it on my skin? Or would it kind of fizzle and not do much, right? Does it react to the air? Does it rust? Those are things that are chemical properties. Now, the only reason we really want to focus on physical and chemical properties is so that we can use that information to determine whether or not a chemical reaction occurred. That's the whole reason why we're talking about these things. So, let's go on ahead and get into physical and chemical changes. Sound cool? All right, let's do it. So, physical and chemical changes. As I said before, physical properties are all about the properties or characteristics of the actual substance, things you can touch or experience or feel or whatever. And chemical properties come about in how that particular substance interacts with other substances. It's reactability, essentially. So when we go into physical changes, well, that's changes to its physical characteristics. It's still the same thing. So for instance, if I take this hammer and I take this glass beaker and I smash this into as many pieces as I can, It's still glass. It's just a different size and shape now. So I changed its physical characteristics, but it's still glass. It hasn't changed into a new substance. So therefore, it's a physical change. I can do the same thing with, say, salt and water. If I mix these two things together, a chemical reaction doesn't occur. This one just dissolves inside of this. This is the solute and this is the solvent. So let me go on ahead and just demonstrate that in hyper speed. Now, as you can see, I've now dissolved the salt into the water here and have salt water. Now, water is still in there. It's still the water molecule. It hasn't changed chemically in any way, shape, or form. It does all the same things that water always does. And the salt in there, well, it's just in smaller pieces and it's mixed up. That's it. It's still salt. In fact, if I were to take my blowtorch and heat this up until it boiled all the water away, I would just have salt left behind. The salt never changed in any way, shape, or form. So this would be a physical change. The water stayed the same, the salt stayed the same stuff. We have to look for things like the change in the luster, or the malleability, or the ability to pull it into a thin wire, or the density of it, or the viscosity of it, or solubility, or mass, or volume. Any of those can be physical changes. How do I change the mass? Well, I just changed the mass. Now this is like half the size it used to be. So, okay, great. And it's also much smaller volume. I can fit these into a smaller place than when they were put together, right? How would I change the density? Well, I would take all of these and crumple them up as tight as I could. And now there's more atoms in a given amount of space, right? So I've just changed the density, but it's still styrofoam. I could take this and dissolve it into something, just like I did with the salt, and it's still styrofoam, it's just been dissolved. So again, this is how you would identify whether or not you have a physical change. But what about chemical changes? Now, if I change what the substance is, and it's no longer what it was originally, it's a different chemical entirely, well, now you've had a chemical change. And one of the best examples of a chemical change is, well, setting something on fire. Anytime you set something on fire, you add oxygen to it. And typically, you break up whatever the molecule you started up with was. For instance, the cellulose that's in this match right here. Well, this is just carbon and hydrogen and oxygen all stuck together in what's called glucose. And that glucose is stuck together with other glucose chains until it makes fiber, cellulose fiber. And that's what wood is. And if I take a blowtorch and I start burning that cellulose, well, the oxygen in the air combines with the carbon inside of the cellulose to create CO2 and water. The water is formed from the hydrogens that were inside of the glucose, and as they bind with the oxygen in the air. So here what you have is a chemical change, because that flame right there, that flame is nothing more than CO2 and water vapor, gas, going into the air. They just happen to release a lot of energy, so it's hot and it glows. When you're looking at a flame, you're just looking at gas moving. That's really it. It's moving and glowing. But that indicates, right here, a chemical change has occurred. It's no longer wood. The stuff that's left behind is any of the impurities and stuff that weren't cellulose that didn't combust. So how am I going to know whether or not the substance changed? Sometimes it's not always easy to tell. Well, there's a few tips and tricks or clues or things to look for, whatever you want to call that, to help you identify whether or not you have a physical or a chemical change. Now again, remember, a physical change, you still have the original substance. It didn't change form. So glass stayed glass, paper stayed paper, Kool-Aid stayed Kool-Aid, right? But if I have a chemical change, well, now I have a completely different substance. Something has changed about it to where it's no longer what it originally was. And in order to ascertain what has occurred, well, that's a little bit more tricky. The great thing is chemical changes generally tend to give you all sorts of information to let you know that happened. If I react something, I'm most likely either going to see the temperature increase or decrease depending on what type of a chemical reaction it is. Anytime you rebond or break bonds apart, you're either taking energy away from the environment or releasing energy, right? And we already know that because right here with a match, with this chemical equation, combustion, I have my fuel source, the cellulose, and what I'm doing is breaking the bonds of the cellulose fiber. And that releases a lot of heat. And that's why we have a flame, and that's why it's shiny, and that's why it hurts when you touch it, right? So a change in temperature indicates that there has been a chemical reaction or a chemical change. Other things would be things like color change. Notice the match is no longer a nice tan color. It's turned black. Well, what's left behind is no longer cellulose. It's changed substances. So of course it has a different color. If we see bubbles when we mix things together, like baking soda and vinegar, when you mix those two together, they create a gas, and that's what bubbles are. They're gas being released. So if I mix two substances and all of a sudden I see bubbles coming up, chances are there's a chemical reaction occurring. If the smell somehow changes, and by the way, before I get into smell, just know you really shouldn't ever smell substances in a chemical laboratory, and you really shouldn't smell things that you've mixed that you know are chemicals at home, because they could put off potentially deadly byproducts that you're unaware of, and, well, you would sniff your last sniff, so to speak. But anyways, if there's a change in odor of whatever it was, well, chances are you have a chemical change. For instance, this match didn't always smell burnt. That burnt smell is indicative of the chemical change of combustion, right? So these are all different things to look for if you're trying to identify whether or not you have a physical or a chemical change. Now, we're going to have some demos, so to speak, and you're going to have to figure out whether or not I'm showing you a chemical or a physical change. And if you need to rewatch this video because you totally tanked this because I didn't do a good enough job of explaining it, just send me an email and I'll go ahead and reset the EdPuzzle thing so you can do it again. Because, you know, I would much rather you learn this stuff than just take a bad grade and go cry somewhere underneath the blanket. That doesn't do anyone any good. And at least it's never done me any good. All right, well, let's go on ahead and get into it. Time for some demos. Demo number 1. This styrofoam cup is now in 2 pieces. Was this a physical change or a chemical change? Demo number 2. Same styrofoam cup from before. Beaker. Acetone. Check this out. I'll take my beaker. I'll put my styrofoam cup inside of the beaker. And now I'll pour some acetone on it. Voila! Styrofoam has been dissolved. Is this a physical change or a chemical change? Hey look, I made snot. Science! This salt water, this blowtorch. If I heat this beaker continuously, eventually this water will boil. So if I get this water to boil with this blowtorch, is that a physical change or is it a chemical change? I have this milky white substance and this clear substance here. When I mix them together, I make a giant mess. Is this a physical change or a chemical change? Next one. I have this blue substance here. and this yellow substance here. When I mix them together, I get a dark green. I know it doesn't look green to you maybe on the camera. Oh, there we go. Yeah, it's looking green. Is this a physical change or a chemical change? This hammer and this rock. If I take this and break it into pieces, do I have a physical change or a chemical change? This clear cup and this sandpaper. If I sand it, it's not so shiny. It's lost its luster. You can't see through it. It's become opaque. Is this a physical change or a chemical change?
This coffee mug rolled underneath my seat at the beginning of the week. And now, it's pretty rank. Is this a chemical change or a physical change? This kettlebell is beginning to rust. Is this a physical change or a chemical change? You tell me. I'm just pumping iron. These plants here in my window are absorbing sunlight, and they're taking in oxygen from the atmosphere, combining it with water to make sugar. Is this a chemical change or a physical change?
Last one. So this 3D printer that you've been hearing this entire video is taking this plastic and it's melting it, basically like a hot glue gun, to make this Mandalorian helmet. So is this a physical change or a chemical change?
Where are your rebel friends now?